So like always, every first chapter of your maths book has been about numbers from the beginning, whenever you started studying your probably your second, third standard or fourth standard, I don't know. But now you are in 10th standard, and you are about to almost cover most of the numbers that you will ever read in your higher studies also. Okay, so numbers can be divided into two groups. What kind of numbers can be there? Can anyone tell me?
Real numbers and imaginary numbers.
Real and imaginary. Excellent. So real numbers is the one which you have been studying so far always. Whether it was when you started with natural numbers, whole numbers, integers, fractions, rational numbers, irrational numbers, all these bunch, whatever you have studied so far, everything has been about this one branch, which is real numbers. Okay. You had never come across the imaginary numbers, and you would not come across that in 10th standard. This comes only in 11th. Okay. So we will not be discussing about imaginary numbers. We are only going to talk about real numbers. Real numbers can be of two types. What are they?
Rational and irrational.
Yes, rational and irrational. Everyone knows irrational number examples.
√3, √2.
Yes, numbers like √2, √3, and so on. √5 and so on, not √4. And even in decimal form, we used to write like 0, 1, 0, 0, 1, 0, 0, 0, 1. Wherever the number is non-terminating and non-repeating. It should not be repeating also, it should be non-terminating. Then it will become an irrational number. But what about rational numbers? Rest of the things. Any number which can be written in the form of P by Q, right? Where P and Q are integers and Q should not be equal to 0. So whatever whole numbers, natural numbers, whatever you have studied so far, all the fractions, they come under rational number. Okay. So I'll just write it in short: natural number, whole number, all the positive, negative, zero, all the integers together, and fractions also. Everything together comes into a rational number. You can actually break it down like this. So you can have negative integers or 0 or positive. 0 and positive integers. So it's not easy way to represent all that in a tree like that, because fractions can also be written, integers can be written as fractions. So think of like that. Okay. So all the numbers you have studied so far, they're all real numbers. Now in this 10th standard, what's different? What are you going to study?
Irrational numbers, sir.
No, that you yeah, you'll be studying little bit of irrational numbers also. That is true. We'll be proving that some number is irrational, like √2. Prove that √2 is irrational. Prove that √5 is irrational, or maybe 2 plus √3 is irrational. Like this kind of questions you will come across in this chapter. Okay, proving that some number is irrational, that will be part of it, but not only irrational. We'll be studying about some property.
HCF, LCM.
HCF, LCM, Euclid's division algorithm.
Sir, ma'am did not teach Euclid's division algorithm. So she said for last year it was division. For last year it was cancelled. So now she said till any confirmation from CBSE. Ma'am would not take that, sir.
No, but I will teach you. Okay, I will teach you
Yes.
because there is no guarantee that it will be deleted this time. So I want to teach you, and we will see if it is not there, we can discard it. No need to practice too many questions on it. That's okay. We can just leave it like that. But I don't want to leave it at last, and so that in a rush, like suddenly they will say it's there. So I don't want to come back to this chapter again and teach you all this again. Okay. So at least for the basics, when we are starting, I will teach you once, and we'll see. We will not spend too much time on this. We'll start solving more questions on this only if we get a confirmation that you'll be writing exam for the whole portion, not any deleted portions. Okay. Yeah. So before we get into anything, there is a small puzzle over here. Euclid's division lemma. There is a puzzle related to that. So let's try to take up this puzzle. All of you have the book, right? So I want you to take some time, 2 minutes or maybe 2-3 minutes, and read this puzzle on your own from here to here fully. Okay, now even if you have not completed reading it, let's follow along with me. Okay. So what's happening is there is a trader moving along a road selling eggs. So he wants to sell eggs. There was an idler, means who was not having any other work to do. So started to get in trade, get the trader into some wordy duel, means started having some argument. Argument grew into a fight, and the basket with eggs, he dashed it, and it fell on the floor. So eggs broke. The trader went to the panchayat to ask for the money to be paid for the broken eggs. Everything was broken, whatever he had with him. So the panchayat asked the trader, how many eggs did you have? How many were broken? So he gave the answer in puzzle. I don't know why he did that. If he wanted money, he should have given the straight answer, but for some reason he gave this puzzle, and now we have to solve it. Okay. So what did he say? If counted in pairs, one will remain. What does it mean? If you counted in pairs means if you take two eggs at a time, one will be left alone. Can anyone tell me what this means mathematically? If you counted in pairs, one will remain. Say that again. It's okay, give it a try. There's no prize or punishment.
2 won't be the factor of that number of x there.
Yes, it means that if you count in pairs means if you divided the total number by 2, 1 will remain, means a remainder will be 2. Remainder will be 1. That's what it means. If you divide the number by 2, the remainder will be 1. Think of a number like 5. You count the numbers in pair means what? You take 2 of them, another 2 of them, 2 plus 2, 4 is done. One last one will be left alone, right? Makes sense? If he had only 5 eggs in that case. But here they're saying that whatever the number of eggs were there, if you counted in pairs means divided by 2, then only 1 will remain. Same way, if counted in threes, 2 will remain. Counted in fours, 3 will remain. Means divide by 3, remainder will be 2. Divide by 4, remainder will be 3, and so on. So before we do anything, let's try to write down this thing mathematically, what it means to say that. So if you divide some number by 2, it can be, let the total number of eggs be x. Okay, let's say he had some x eggs. Now this x, when you divided it by 2 times of some number plus 1, it will become this number. Division algorithm, everyone remembers it? If I have total number of...
Sir.
Yes, tell me, Medula.
Have you started recording, sir?
Yes, I have.
Okay, sir.
Okay. So what I'm saying, there are x eggs and you are dividing it by 2, means x divided by 2. You will get some quotient. Let's call that quotient as p. And you will get some remainder. And that remainder has to be 1. Correct? So can I write it like x is equal to 2p plus 1. Everyone remembers this division algorithm? We did this in polynomials chapter, but it is handy over here also. We know that dividend is equal to divisor into quotient plus remainder. So dividend is x, which is the total number of eggs. Divisor, we are dividing the number by 2, and quotient could be some number like p. We don't care what that number is, but when you did a division, the remainder should be 1. So is this statement clear to everyone?
Yes, sir. Yes, sir.
Yes, sir.
Okay, so this was the first statement, that when you did a division by 2. Same way, the same x number of eggs, when you did a division with 3, quotient will be some other number, not p this time, but maybe let's say q. But what will be the remainder?
2, sir.
Counted in threes, the remainder will be 2. So the remainder should be 2 this time. Same way, same if you did with, not q this time, but if you did a division with 4, let's say the remainder is r, not remainder, the quotient is r this time. And remainder is how much? When you did a division by 4,
3, sir.
it should be 3. So I will write the rest of them. It's very simple. So when you did a division by 5, quotient should be PQR, let's say S, and remainder should be 4. 6 T plus 5. When you did a division with 6, it should have 5 as a remainder. And at last, finally, if counted in sevens, nothing will remain. What does it mean?
7 is a factor.
Yes, the number, whatever it is, it's divisible by 7, correct? Remainder is 0. So this one gives me a very big hint that whatever number my x is, it's divisible by 7, right? So it's a good big hint. Let's keep it separate. Not separate means remember that thing. Okay, now at last he's also telling my basket cannot accommodate more than 150 eggs. So whatever number this is x is, this x has to
Less
be,
than 50.
yes, x has to be less than 150. Now, very easy hint. Just now we first understood that it is a multiple of 7. So let's try to write down some multiples of 7 which are just less than 150. Because of course he's out for selling, so he will try to keep maximum number of eggs in his bucket, right? So what is the number which is divisible by 7 and just less than 150? What is that?
147.
Yes. So to find that, 7 2s are 14, 7 1s are 7. So there's a 3 remainder. So what we can do, if we subtract 3 from this one, 150 minus 3, 147. This is the number which is divisible by 7. So 147 is the first number like that. So 147. Let's write some more numbers because this condition is satisfied over here that it is divisible by 7. But we need to look at all these conditions also. No? When we divide by 2, only 1 remainder should be there. Divide by 3, only 2 should be there. All these conditions should be satisfied. So it may not get satisfied by this number of x. So let's write down few more multiples of 7. Just below this one, under this one. So if 147 is this, which will be the next multiple of 7 below this, less than this? Next multiple of 7, less than 147?
140.
Of course, it will be just 7 less than that. It will be 140. Next one, 133, correct? Then 126. And then 119, 112, 105, and so on. We can keep on writing all the multiples. Let's keep it only this. Let's try to check whether any one of them is there our answer or not. Okay. All of them are multiples of 7. So all these numbers satisfy this condition. Correct? Give me a yes or no, guys. All these numbers satisfy this condition. Yes, tell me.
Yes, sir.
Now, instead of going and one by one checking all of them, try to be little wise and look at these things. This number is not divisible by 2, right? Because when you divide by 2, there should be a remainder 1, correct? So this guy 140, 126, 112, these numbers are divisible by 2, so we can straight away remove them, correct? Okay, same way, this number is not divisible by 5 also, because when you divide by 5, the remainder should be 4. So 105 is also out. See how quickly we eliminated all those numbers just by thinking about these two rules, that this number is not divisible by 2 and this number is not divisible by 5 also. Now let's use other conditions also. So these three conditions are already satisfied now. So whatever numbers are remaining, 147, 133, 119. So only these three numbers are remaining now. And in these three numbers,
Sir, 147 is divided by 3, sir.
it is, yeah, 4 plus 1, 5, and 5 plus 7, 3. So like, okay, very good. So when you divide by 3, it should not be divisible. It should leave remainder. So 147 can also be eliminated. Excellent. Look at these two numbers now. Which is the one we should pick? Let's do the division by 5. Easiest one, right? Divide this number by 5 and see whether remainder is 4 or not. 133 divided by
3.
5. So as you can, it's very simple that when you divide it by 5, 130 will be divisible, 3 will be the remainder, right? Common sense, no? Everyone understands that 3 is the remainder. But what did I say? What did the guy say? If you divide it by 5, the remainder should be 4. That means this can also be eliminated. Now what is remaining? Only 119 is remaining. So now let's check and confirm whether all the rules are getting satisfied for 119 or not. Start from the beginning. Divided by 2. Of course, it will not be divisible, and 2 always leaves a remainder 1 only. So this condition is satisfied. Everyone okay with that? This condition satisfied for 119. Divide it with 3 and see whether 2 is a remainder or not.
Yes, sir.
Okay, so 119 when we divide it by 3, 2 is the remainder. So this condition also satisfied. Excellent. So far 119 is doing very well. Let's check the next condition. Divide it by 4 and see whether the remainder is 3 or not.
Yes, sir.
Yes, sir.
Excellent. So this guy is giving me good hopes. Looks like this is our number. But let's confirm. Check the other condition. Divide it by 5 and see whether the remainder is 4.
Yes, sir.
Yes, sir.
This is also done. Divide it by 6 and check whether the remainder is 5 or not.
Yes, sir.
Yes, sir.
It is. Excellent. And of course, we had picked only numbers which are divisible by 7. So this number is obviously divisible by 7. So all these conditions are satisfied.
Sir, I'm having one more doubt, sir. If 199 is getting divisible, then there can be many numbers, no, sir. Even below 105, also like 98, 91.
Yes, you can keep trying, and then you have to check for all numbers whether this condition satisfied or not. Okay, but what did he say? He said that my basket can take a maximum of 150. So he will try to pick the number which satisfied all these conditions and it has maximum number of eggs. So
Yes, sir.
go down below.
Yes, sir.
Okay, fine. So everyone is okay with this puzzle now? The answer is how many eggs this guy had? 119 eggs. So now this guy will get his money. Okay. But while doing all that, we have learned a very powerful idea that any number, whatever number we have, can be written in this division algorithm form. Dividend is equal to divisor into quotient plus remainder. This is very important idea, and which is what is called your Euclid's division lemma. This theorem 1.1, the first theorem of this chapter, Euclid's division lemma, it talks about the same thing. If I have any number A and B, let's say A and B are two numbers, okay? And I'm saying that A is bigger than B, so B is smaller number. So whenever you have that kind of a thing, what you do is you divide your number A by B. So A becomes what? Dividend, and B becomes the divisor. There will be some quotient Q and there will be some remainder R.
Yes, sir.
So if we have like this A, B, Q and R, it can be written as A is equal to B times of Q plus R. This is what Euclid's division lemma is. But you might be thinking, what did this Euclid do? We already knew this as a division algorithm. Why is he telling me this again in the different form? So this is true actually, okay? You read this part of the story. So this Euclid's division lemma is an idea which was already known before itself, okay? Well-known idea. That's why it's called a lemma. It's a proven statement which people already knew, but it was written in his book. For the first written record of this thing has been found in Euclid's book. That's why it's known by his name, Euclid's division lemma. Okay, and there is few subtle things to remember. That remainder will always be less than your divisor. This we already know, right? When we do some division, remainder will always be less than the number with which we are dividing. R is going to be less than B. And of course, it will be 0 or more than that. No, remainder can be either 0 or greater than 0, and it should be less than the divisor itself. Are you able to understand with this? Let me take an example and then try to explain, okay? So let's say I take a number 7 and 153. Is it divisible by 7? No. Let's say take some bigger number, 347. Yeah. So these are the two numbers. Now, which one will be my A and which one will be B?
Sir, A is 347, B is 7, sir.
Why did we do that? Because we said A should be greater than B. When we are taking our numbers like A and B, the bigger number we call it as A and the smaller number we call it as B. Okay. Is everyone okay with that idea?
Yes, sir.
Okay. Now let's do the division and find out the Q and R also. 347 divided by 7. Let's hope that it's not completely divisible. How many times it will go? How many times?
4 times.
Yes.
4, sir.
What is remaining?
67.
67. So
63. 49, sir, quotient.
7 9s are 63. So what is the remainder? 4.
4.
Now,
4.
can this remainder ever be greater than 7?
No, sir.
It will always be less than 7, no? That is what
Yes.
this idea tells you, that the remainder R will always be less than the divisor B. Okay, in terms of numbers it's written, but you should understand that A can be written as 7 times of 49 plus the remainder 4, and we understood that remainder will always be less than 7, of course, because if it was greater than 7, then we could go one more time than that. We would have not gone 9 times only. But in this example, it is 9, but think about that, okay? Remainder will always be less than the divisor. That is what simple idea they have written in terms of maths. How do we write it?
Sir,
Yes, tell me.
Sir, in terms of polynomials, it will be different, isn't it?
No.
Sir, in terms of polynomial, I mean, it is necessary in that also that the remainder will be less than divisor.
See, in terms of polynomial, when we have polynomials or variables, they don't have any fixed value, right? If I tell you 3x square minus 1 and I tell you another polynomial 2x plus 5, can you tell me which one is bigger or which one is smaller? You can't tell, no, because they don't have any fixed value. Their value depends on x. So if I put x equal to 1 here, this will become something. If I put x equal to 100 here, this will become something else. So how can I compare them, that which one is bigger or smaller? So polynomials, we cannot compare that which polynomial is greater and which polynomial is smaller. This is not a right comparison because they don't have any fixed values. Did that make sense?
Yes, sir.
Now, having said that, I'm saying that their values are not fixed, so we can't compare them. That remainder can be greater or not, but we learned about a rule, no? There was a rule in case of polynomials. What was the rule? Anyone remembers?
The degree of Rx can be greater than Gx.
No, it will always be less than gx. No, that's what we learned. The degree of Rx is always less than degree of gx. Okay. So in terms of polynomials, we were talking in terms of degree, not the value directly. And why were we not talking value directly? Because just now I explained you. Values of polynomials are not fixed. So we can't compare them. Which one is bigger or which one is smaller. But degree can be compared. So in terms of degree, Rx has a lower degree compared to the Gx, which is the divisor. So there also we have that rule, but in terms of degree, but in terms of number, we don't have, we have in terms of value itself. The value of the remainder is less than the divisor always. Make sense, everyone?
Sir.
All right. So that's what your Euclid's division lemma is. Very simple idea, which you already knew, but it's just written in terms of in words. Okay. Okay, but why is it important? Why they are teaching you this thing, which is like a baby stuff, which you already knew? So this stuff has some applications. Okay. If you know this idea that A can be represented as B times of Q plus R, where R is greater than 0, greater than or equal to 0, but it is less than B. So this statement, everyone understands fully?
Yes, sir.
Yes, sir.
Okay. So it has some applications like understanding the divisibility rules. Okay. It has some applications related to divisibility rule, and it has also been used to find the HCF of some numbers in Euclid's division algorithm. So you can use Euclid's division lemma, and using this lemma again and again with along with following some more steps, you can actually find the HCF of two numbers. Okay. So, but we will not go into that today. That's it for today. You just have to be very sure about understanding this idea that any number A can be represented in the form of BQ plus R, where B is the divisor, Q will be the quotient, and R will be the remainder, and R has to be always less than B, and it has to be greater than equal to 0. All right. Anyone has any questions from what we have discussed today?
No, sir.
Okay. Fine then. That's it for the maths class, guys.